Hi, kids. Hey, I wanted to go over the little simulation lab that you did. So you had an air puck, okay, and then to start, when it was at rest, there was a little block holding it back. So this force and this force canceled each other, and then this force and this force canceled each other, and hence the puck was at rest and stayed at rest. Newton's first law, because an object at rest stays at rest unless the net outside force acts on it, and there was no net outside force. Okay, and the block was released, so you had something like this. So these two forces cancel each other out. So then your net force was equal to your applied force pointing this way. So whatever that applied force was your net force. And then you were supposed to make some graphs. You were supposed to graph net force versus acceleration. And when you graphed it, hopefully it came out to be linear. And remember, anytime you have a linear thing, I always want you to think about y equals mx plus b. But then, did you graph y? Nope. You graphed f net. Okay. Did you graph x? Nope. You graphed a. And then what did the slope turn out to be? Well, the slope actually turned out to be mass. So it actually is m. Okay. And this is the relationship. Now, most of the time, when I have you write out Newton's second law, that's what we're going to write. We're going to write F net equals ma. Okay. If you look on your formula sheet, it's not written that way, and we'll talk about that in a minute. And then you were supposed to do another experiment where this was the one where you kept the mass constant. You're supposed to do an experiment where you keep the net force constant, and you graph A and M, and this came out to be an inverse relationship. So then you had to linearize it. And when you linearized it, you had to put A here and 1 over M here. And it came out to be a line. And then again, hey, look, I got a line. So I should be thinking about y equals mx plus b. Did I graph y? Nope. I graphed A. Did I graph x? Nope. I graphed 1 over the mass, and then in this case, the slope came out to be the net force. So really, I end up with A equals F net over M. Now, if you look on your equation sheet, this is what's on your equation sheet, okay? And here's why the College Board writes it this way. First of all, they put little arrows. The little arrows are to remind you that, hey, guess what? Acceleration's a vector and the net force is a vector. But the reason they write it this way as opposed to this way is they're saying the acceleration depends on the net force and the mass. So whereas up here, the net force really depends on your picture up here, okay? It doesn't really depend on M and A, so that's why the College Board is going to write it this way. A equals F net over M. Or you'll also see on there, they write it like this. Sigma F over M. Now, what this little thing means, if you've never seen this means the sum of the forces. Okay, but it's the same thing. This is the net force. If you add up the forces as vectors, you get the net force. All right, hope that helps. Bye, kids.